So let's look at this example. I have a container with 3 red balls and 2 blue balls. Okay? And then I'm going to select 2 balls. I'm going to ask you, what is the probability of getting 2 blue balls? Don't rush. You always rush in the answer. See, this part should not rush. Should always do a tree diagram, and should always consider step by step. Consider this. We have multiple stages. You're selecting one. If you're selecting 1, 2 over 5. You said 2 over 5. You are right. 2 over 5, but that's only for the first ball. So the first ball to be blue is 2 over 5. To be red, the probability is 3 over 5. Now the second ball, if you select it, still can be blue or red. So what is the probability the second is blue, given the first is blue? 2 over 5 also? Are you sure 2 over 5? 1 over 4. Someone saying 1 over 4. Yes, it depends, exactly. It depends if you took the ball and did you put it back or did you keep it? So that gave us 2 options to think now. Okay, so when you select from a large population, it doesn't matter. Like the previous example, when you're selecting a student from so many, it didn't matter. Because big population doesn't affect much, when you take 1 or 2 or 3 or even 10. But if you select only from 5 or 50 or any number that you know, then taking 1 will change the distribution of colors, right? So in this case, a very important question you have to ask yourself. After the guy selected the ball, did he put it back or not? Usually, if you take something, do you put it back? Usually not. If you take something, you actually want to use it, you want to buy it, something like that. But it's sometimes given, sometimes not given. So if I say with replacement, it means replace, which means you put it back. That means you put it back. Okay? But if I say without replacement, which means you keep it. And usually this is not mentioned. You know why? Because that's usually the case. Usually when you take something, you don't put it back. So this is the question. Didn't mention anything at all. So if it didn't mention anything at all, it means you actually took it. Because that's usually normally what happens in life. You buy a marker, you take it, you keep it, you go to the counter and you pay for it. Okay, so the probability according to this example of blue given blue will be 1 over 4. Because you took 1 from the 5, so the remaining is 4. And the probability of red given blue, you took the blue already, right? That's 3 over 4. And of course, when you add them, you get 1, and that's important to remember. Okay? So if you said 2 blue, that's enough. I don't need to continue the tree diagram. 2 blue means blue, blue, right? And the blue, blue means 2 over 5 times 1 over 4. So I use a multiplication rule to get this outcome, which will be 1 over 10. Okay? Clear that? Any question about that?
The 1 over 4 is for what?
1 over, this is a 2 over 5, the probability of blue, and this is 1 over 4, which is blue given blue. But remember the outcome here is BB, right? So it will come from where this outcome? From this branch, right? So we just multiply the probabilities of this branch that lead to this outcome. Right? This is the multiplication rule. Remember, what's the lesson today? Still in the multiplication rule. Okay? So we just multiply the probabilities on the branch that lead to this outcome.
How is the blue given blue 1 over 4?
Because given blue means you took blue, so just hide this blue for a second.
You took 1.
I took 1, so just hide it. So remaining 1 out of the total, which is 4. If you're selecting now from 4, if you take 1, now given blue means blue is taken. I'll just take it out. So now you're selecting again, second time.
You say when you say given something, you just choose that population, not the whole population.
No. That was in the high frequency table. Now we're looking at the concept of given. Given means something already happened. What happened here? I already took the ball. So the distribution of color changed. Given is a piece of information. In general, the word given means I am telling you something happened. That's a piece of information. That's its original meaning. So what is the piece of information? The ball, first ball selected is blue.
Yeah, the first one, when you say given, you choose that only.
That was when you had the frequency table. That was when you had a two-way classification table. Now we're moving to tree diagrams. Okay? So when given male or given female, which means I'm telling you he's male, so it's like selecting from the male. That was in the table. Now we have tree diagram. I'm telling you selecting from the whole container. I'm saying given, but it's still totally different because when you have two-way classification, the two steps of the tree diagram was only one selection. Now the two steps are actually two selections. So it's totally different example. Yeah. If we replace it, then there will be still 2 over 5. This will be 2 over 5 also. If we say with replacement, and suppose I say here with replacement, then this will become 2 over 5. Okay, but I didn't say that. So, okay, and anyway, I just put the ball back. So we took the ball, so 1 over 4, and then the probability of red is 3 over 4 because it will be 3 red and. Okay, now clear? So this question, we just answered the question. Probability 2 of them blue. How about let's do another one. Find the probability 2 of them. Find the probability that 2 of them are red. Red. Yeah, it's just exercise for you. Why don't you try that? Just continue the tree diagram and try to get the red. Yes. Yes, very good. Yeah. Just continue the tree diagram. Try to fill the tree diagram, the missing part, if you understand what happened. I'll give you, 5 minutes? 3 minutes? You have a paper? If you have a paper or pen, try to graph this tree diagram. Start graphing because we need to start. Be active. Try to continue the tree diagram. Please continue the tree diagram. Just fill it all with all possible outcomes. And get the probability that both of them are red. Yeah. Yes, what's the answer?
3 out of 10.
3 out of 10. Okay, so the second time you select, it can still be blue or red. Given the first one red, the total number of red becomes less, become only 2 remaining, and the total becomes 4. So you have, in fact, 2 over 4 here, and you also have 2 over 4 here, right? The chance of getting blue will be 2 over 4. Chance of getting red. Now you want red, that's the outcome. Then you just multiply the 3 over 5 times 2 over 4, and when you multiply them, you will get 3 over 10. 3 over 10. So the probability of RR is 3 over 10. So this will be 3 over 10.
So all is 2 red balls?
Yeah, 2 red balls, yes. Okay? Find the probability that you have a blue ball followed by a red ball. Find the probability of getting blue followed by red. Or blue then red. Yeah, so the word is important. I have to say something here. I have to say followed by, I have to say then. I have to show you the order is important. That the ball is the first ball is blue and the second is red. Okay? So that's how I use that. I use the word then, I always use blue then red. Will be the same result actually. It's 2 over 5 times 3 over 4, which will be actually also 3 over 10. Okay?